Hi and welcome to this video. This is the first video of a whole series of videos and it will be about swords. European swords to be more precise. I try to explain technical features of the European sword that interact with each other, knowing of the complexity and therefore of the unavoidable mistakes I will make. But I feel there is a gap on this topic and I would like to contribute to close it. So, welcome to this channel. In this video series I will present a longsword as an object of investigation. However, this doesn't mean that this evaluation cannot be used for other swords. The purpose of the different sword features will be very similar for European swords in general. So even if you don't have a longsword, you will be able to apply this information to other swords as well. The first stop in our journey of discovering the functions of a European sword is the weight in total. Now, different swords have different weights, of course. But it is also true that there has to be at least an upper limit for a human to move a sword efficiently and a lower weight limit for structural stability, stiffness and impact power by the use of enough material. So what is a good weight for a European sword with a double-edged long blade and why? The general weight of swords is remarkably narrow and this supports the fact that there is a certain weight range where the sword can live up to its maximum potential. In the 13th to the 15th century, the average weight was 1.5 kilograms. Most swords are in between the range of 1.2 and 1.7 kilograms from this area. In the 15th century, swords weight was an average 1.5 kilograms also. Again, most swords are between 1.2 and 1.7 kilograms during this time. In the 16th century, swords are between 1.2 and 1.7 kilograms, again with an average weight of 1.43 kilograms. So, from this data, we can see a certain weight boundary. Swords for special use not included. Since I have a sword with 1.23 kilograms, one with 1.45 kilograms, one with 1.56 kilograms, and one with 2.3 kilograms, I was able to study the weight issue firsthand. And I can confirm this weight approach is absolutely right for HEMA style sword actions. There is definitely a weight threshold that if exceeded overshadows the performance of a sword negatively. If you are using HEMA techniques described by Hans Lichtenauer in 1370 till 1390 and reflected again in the manuscripts written by Hanko Döblinger und Sigmund Ringeck, and you use a sword that is heavier than 1.7 kilograms, for this fighting style, the sword will let you feel its weight. The point of balance, pivot point, and mass distribution will not be able to compensate the heavy inertia of the sword. The sword will feel heavy and slow, and this behavior will worsen the more weight the sword has. The weight will become a more and more dominating factor if you exceed 1.7 kilograms, and 1.7 kilograms is already on the upper limit. There are a few swords that want to be heavier because of their special use, but a typical sword demands agility and versatility. One requirement for agility is not to get too heavy and stay in the range of 1.5 kilograms or even less. So yes, if weight gets too heavy, no technical trick can hide this fact anymore. My sword with 1.45 kilograms behaves very different than the one with 1.56 kilograms. A difference of 110 grams. If the sword is within the mentioned weight boundaries, it can be optimized with a few measures. Let's see.
The most important factors are the mentioned overall weight itself, but also the weight distribution within the sword, its point of balance or center of mass, where the pommel and the blade take an important role, the pivot point which occurs when an impulse is applied, and with the long sword the length of the hilt and the possibility to grab it with two hands therefore. Minor factors of a better handling sword are the grip size and the shape of it with its surface profile. The oscillating nodes, also called the point of percussion, and the form and dimension of the pommel. We will of course examine all those features closely. Let's start with the point of balance, assuming that the sword lies in between beneficial weight boundaries. The point of balance is the static pivot point of the sword, not to be confused with the dynamic pivot point, which I will cover later. If I throw the sword into the air and no outside force is applied anymore, and only the mass inertia is active, the sword will turn around its center of mass, which is the point of balance, if the initial momentum allows it. So after accelerating a sword, the sword will turn around its mass center, except it was thrown like a spear. What happens while we accelerate or decelerate a sword will be for later. It is a good idea to have the point of balance close to the hand that holds the sword. The opposite of such an approach is an axe or warhammer. An axe has the center of balance very far away from the grip and is therefore, let's call it blade heavy or forward heavy. Once an axe is accelerated, it cannot be stopped easy from the normal grip position except it hits something. So the impact power, because of the concentrated weight at the front, that means in the head, is very good. Our sword, however, should not be too blade heavy. We do lose impact power by having the point of balance close to the crossguard, but we gain agility and therefore we can handle the sword faster and easier. The sword can be managed also with one hand now, and it doesn't pull too much when swing around. The impact of the blade on human body parts remains lethal enough with this setup. So that's the main idea of a close center of balance to the place where you grab the sword. Considering the lethality of the sword, I know that little impact power can be a disadvantage if it comes to body armor, which will be covered in the future. But don't think only as the body armor being the enemy of the sword. Actually, body armor freed the second hand from the shield and allowed the sword to become a true primary weapon that can demand the full attention of the bearer. Now, if you think the point of balance describes the behavior of a sword already, you are wrong. You can have a perfect point of balance, but the weight distribution of the sword is as such as the main weight concentrates at the pommel and the tip of the blade. Such a sword will handle slow and horribly, even if it is within the weight limits we mentioned earlier. The weight distribution behaves principally as such as the more weight is concentrated at the place where the sword is held, the lighter it feels and the faster it gets, but loses impact power accordingly. We can say the further the weight distributes away from the grip, the slower and heavier the sword gets, but its impact power will be increased at the same time. Having said this, the conclusion to just put the main weight as close as it is possible to the hilt would be wrong. There is a very elegant solution to maximize the desired behavior of the sword by not obeying the weight distribution formula. While weight concentrated at the hilt sounds good, there is a way to reduce the total sword weight by doing the opposite. The pommel can reduce its own weight as a counterweight to the blade by moving it to the very end of the hilt, taking advantage of force by means of a lever. This is especially apparent on long swords, which have very long hilts. So the weight distribution has to be compromised to be able to reduce the general weight of the sword and therefore increase positive behavior. The sword compensates the less optimal point of mass concentration that is put further away to the end of the hilt by getting less heavy. Remember also, the lighter the faster. Otherwise the very smart blacksmith of the medieval times could have just made a tang larger to get a counterweight on the hilt. So sometimes a less optimal solution of one property can benefit the others. It is most important that we keep the weight limited. If you have a not so perfect balanced sword with only 1.2 kilograms, you still will be delighted about its easiness in handling. The mass inertia will square its heaviness by doubling the speed. People without sword experience do prefer heavy, if not to say too heavy swords, because of their assumed power by weight. But it feels very scary to have a slow sword in your hand once you handled fast ones. On the other hand, you have to have a certain minimum of weight and therefore enough material to give a two-edged sword a minimum of stability and impact power. I will cover very light disfigured swords in the future. This topic is just too rich that I have to leave a lot for later. The weight distribution of the blade itself is very apparent in typical medieval swords and favor a mass-rich blade base and a less massive top of the blade expressed in the distal taper and profile taper. This goes hand in hand with our observation that the mass focus should be close to the hilt, and luckily a two-edged blade demands that shape for obvious reasons. However, there's more room to play with. As the blade tapers to the point, it has the desired mass distribution naturally. But we can use a trick to remove weight by still keeping the blade strong enough. One of the most successful approach in doing so is to give the blade a fuller. The fuller allows to take away additional not needed material in order to lessen the weight of the sword, or to widen the blade with no extra material added. This allows for a very wide blade base, sometimes up to more than 5 cm, without getting too thick where the central ridge would be. A thick cross section makes the blade stiff but hinders cuts to go deeper. So we have a disadvantage in blade stiffness, but we increase the cutting penetration ability because of a thinner cross section. We can also increase the sword's agility because of less weight. It seems that weight distribution has to submit to weight loss if it is in competition to each other. In order to maximize the weight loss by moving the pommel further away, the tang has to get very tight, which causes in return trouble if the hilt is not done right. But I will talk about this issue at the end of this video series. After talking about weight distribution and the weight itself, we have to talk about the pivot point, or the dynamic pivot, how I call it. For this we have to start with simple examples. Let's take a normal homogeneous staff. The staff is hanging in the air. The center of balance is of course exactly in the middle of the staff. What happens if the staff is pushed at the point where we would grab a sword normally? The staff doesn't turn around the center of mass in this moment anymore, but it turns around at another point. As long as there is an accelerating or decelerating force at the grip position present, the staff will turn around this created pivot point. The closer the force initiation is to the point of balance, the further away goes this dynamic pivot point. If the force initiation point is on the point of balance, two pivot points in opposition to each other appear and will cancel each other out. The staff will deflect sideways, but no rotation will be caused. Note, a pivot point can also appear beyond the physical boundaries of the blade. If the weight distribution is changed, the pivot point will mostly appear somewhere else, but doesn't have to. However, the rule of the closer the force initiation point is to the center of balance, the further the pivot point goes away and vice versa, is still intact. Unfortunately, as you can see, you can have a very unfavorable weight distribution and still have the point of balance and the pivot point at a good spot. While it is true that a good sword should have the right circumstantial factors, like point of balance close to the crossguard, pivot point at the upper third of the blade, and the overall weight within tolerance, those factors are still not sufficient enough to come to a final conclusion about the sword's behavior. If the mass distribution is not good, or the mass distribution is good but the weight doesn't correspond with the sword, it will not handle well. The easiest way to find out if a sword behaves well is to try it, but this demands the ability to move it the right way. We are talking about HEMA now. The so often mentioned factors, point of balance, pivot point and overall weight, cannot ensure you a good sword, but they indicate a bad one. If one of the mentioned factors is totally off, for example, the weight is 2.3 kilograms, you can stop right there and suppose that the sword will not perform well. Except we talk about a Panzerstecher, TAC, which is a special use sword or a great sword, Biedenhänder. Also, if the point of balance is very off, let's say in the middle of the blade, the sword cannot perform to its possible abilities. It will be blade heavy and slow, but could be still a good cutter. As a whole concept, it won't be convincing though. The pivot point is actually more forgiving and shows itself only during acceleration and deceleration. A pivot point helps stabilizing the point of the blade during guard changes, which doesn't mean that this is not possible without the right pivot point. I think the point stabilizing factor depends more on someone's practice with the sword than the cooperating pivot point. But it is a good idea to have the pivot point at the sweet spot of the sword because of other reasons too. That brings us to the points of percussion or oscillation nodes. The blade length and stiffness and weight distribution cause a certain oscillation behavior of the sword when hit at the flat side of the sword. Normally the pommel is most suitable to be hit in order to let the oscillation appear on the sword, but you can hit it anywhere along the flat side, and the oscillation behavior of the sword will always be the same. Now, a oscillating body will have a 0 point where the opposing amplitudes cancel each other out. In a European sword you will have two of those 0 points, also called oscillation nodes. One is best on the handle where you grab the sword, and the other should be around 1/3 from the point inward. This is called the sweet spot. People will tell you, if you like cutting exercises, you should hit the target with the sweet spot. Well, in fighting and deflecting opposing blades, this becomes impossible. But with static targets, you could use the sweet spot. This technique causes less vibration on the sword when impacting the target, and the second oscillation node on the grip reduces unnecessary vibration on the grabbing hand, and the blade behaves stiffer there. Since the second oscillation node is always active because your hand is normally on it, the first one on the blade is not as efficient as you may think. This brings me to another test. Now I go back to the pivot point. Here you can see 3 marks on the blade. The green is the center of balance, the blue being the oscillation node, and the yellow is the pivot point. When you hit a target below the pivot point, the sword will push against the inside of your hand, depending how far away you hit from the pivot point. If you hit the target above the pivot point, closer to the point, the sword will push against your fingers. If you hit the target with the pivot point, then you won't experience a push to either sides. Now imagine the pivot point being at the sweet spot, and you get a very stable and very controllable behavior when you hit targets. The force on the handle and tang while hitting targets is minimized and helps to avoid overstressing the sword. The blade is at the oscillation node stiffer than on other points, which is a very good behavior. This stiffness should also be felt on the node where you hold the sword with your dominating hand. The oscillating node is normally called the sweet spot, but in my observations the pivot point overrules it by its effect. Oscillating nodes stiffen the blade especially from the flat, but if you parry an attack with your flat you won't have the time to make sure that the opponent's blade will hit your upper oscillation node. The oscillating node on the hand at the grip is most beneficial though, and will always be applied. Note that the speed of the blade is at the point the fastest and slows down the more you go towards the hilt. Interestingly, even though the pivot point experiences a higher blade speed compared to the collisions on the strong of the blade, it doesn't bounce as high. The strong of the blade bounces higher even though the impact speed is lower compared to the pivot position. Of course, impacts close to the point cause the highest blade bouncing. So what can we learn from this assumption? I feel the pivot is principally more dominant in giving the blade strength and impact power than the oscillating node. So I would say if the pivot point is on the oscillating node, you should hit the static target definitely there, of course. If the pivot is very close to the point of the blade, you should go for the oscillating nodes more inward. If the pivot is close to the oscillating node, you should hit with the pivot point. The only reason why you ignore the pivot point close to the point is the blade's unfavorable stability at this position. Watch those sound patterns. Even the sound shows the pivot impact as more beneficial. Unfortunately, in a fight, your concern should not be the pivot but the enemy. But for cutting tests, very interesting, I would say.
Before I finish this first video, a few more thoughts about the pivot point. With our last examination we have seen that the pivot point causes excellent behavior on the sword blade by impact. The question of course is now, what is better? A pivot point at the point or a pivot point on the weak more inward? Well, there are some more things to put into consideration before we come to a conclusion, or maybe we don't have a conclusion even. I would say, first of all, don't think that there is a perfect sword. Don't think that the pivot point should be here or here. I don't think that's the point. I think the point is to be able to have the pivot point, like the weight, like the point of balance and everything else, within reasonable limits, and that should give you the possibility to learn about your sword and to use it at its best. So concerning the pivot point again. If you have a blade where the pivot point, like on this sword, is more inward on the wick, you have an excellent behavior by impacting there. No doubts about that. And you will have a pretty good behavior the more you go towards to the hilt, because even though that you go away from the pivot point, the structural strength of the blade increases towards to the hilt, and this adds up to a good behavior too. And don't forget, when I hit more inward to the hilt, away from the pivot, the sword pushes against the inside of my hand. That is not bad at all. If I hit something beyond the pivot point, in this case close to the point, the sword will push against my fingers. And this is honestly not so good, because it causes also a bouncing back of the point towards me. So with this setup, you have a sword that can be as a cutter for static targets. Excellent, because I can really use that spot to have the best behavior of my sword. And a pivot point that comes more inward also tells me that the sword has a certain blade heaviness that allows me to cut good. So, but the behavior on the point itself, away from the pivot, beyond the pivot point, is not good at all. So I have a sword that is bad here, if it comes to slashing, excellent here, and average here. If I put the pivot point to the point of the sword, that causes that over the full blade length I have actually this push against the inside of my hand. That is, on my opinion, overall the better behavior. I don't like when the sword pushes against my fingers. So against the inside of my hand, that feels good, and it's not a bad behavior at all. So in this case we can say the sword will probably have not a very good, no, I have to say it differently. The sword will have not a special spot where it behaves excellent, but it will have over the whole blade length a good behavior, a average behavior, let's say. And that's not a bad approach either, because think about it. If I have to do a fight against somebody, theoretically of course, I'm not concerned about if I hit him or his blade with my pivot point. I'm concerned about surviving, and I'm concerned about hitting him wherever I can, even if it means that I have to use the cross guard or the pummel. As you know, those are all techniques that you can use by fighting. So both approaches have their pros and cons, and I think you should get to know your sword, you should talk to it, you should try it, and you should know how to use it efficiently. And if it comes up to static target cutting, you can even put this knowledge into action. So thank you for watching this first video. I hope you survived my Arnold Schwarzenegger accent, and it would be nice if you would get curious enough to check out my second video. So I'll be back.